NextPCB is a leading provider of reliable PCB fabrication and assembly services for engineers, startups, and businesses worldwide. Specializing in quick-turn prototypes to mass production, we offer multi-layer, HDI, flex, rigid flex, and metal core PCBs with strict quality control and superior customer care. Our advanced facilities ensure reliable performance for applications across consumer electronics, automotive, medical industries, and more. Embracing Industry 4.0 digitization, we streamline the entire electronics manufacturing process to give you competitive pricing and fast lead times, without compromising on quality. And our user-friendly online platform provides instant quotes, order tracking, and full transparency. In addition to PCB fabrication, NextPCB offers comprehensive PCB assembly services including global parts procurement, testing, certification, and box builds. Our 36 automated assembly lines include advanced inspection tools such as SPI, ALI, and X-ray, reflecting our commitment to quality and reliability. Choose NextPCB for exceptional electronics manufacturing solutions you can depend on.
You can see the NextPCB link by going to the More under this video. Click that, scroll down, and right here is check out our sponsor, NextPCB. Thank you. Welcome to Tech Talk 131B, increasing the current output to 2 amps of your JAMECO dual adjustable power supply. As you recall in our last video, we had added our power transistor NPN, which was going to act as a current conduit for the positive side, and we'd have a PNP for the negative side on the LM337T. We know that the LM337T and the LM317T can only put out 1 amp by themselves. So what we're doing is we're using them to act as a Zener diode or act like our voltage regulator, feeding into the base of the NPN or PNP, and that voltage will be the voltage out of the regulator minus the VBE junction of the transistor. The transistor is acting like the current conduit for the power. And as you recall, we had added the transistor on the positive side and applied 10 volts. But when we put the 5 ohm resistor in the 10 volts, we lost all our energy. And that is to do with a thing called the power triangle. The power triangle is shown in figure 2, which is right down here. What we have right here, we're going to go over that in a second. But we're going to use this pint of beer to really show the relationship between the 3 vectors, the apparent vector, the reactive vector, and the real vector. This beer, as you can see, the head of beer, wasted beer, is wasted electricity. It can be referenced as that. And it's measured in kilovolt amps reactive. This is your reactive power. Your real power is the usable electricity, the real good beer, and it's measured in kilowatts. But the apparent power is the vector squared sum, square root of the sum of the squares of these 2 vectors. The reactive power squared, the RMS value of that, and the RMS value of the real power squared, summed, and the square root of that. As you can see right here, this is your apparent power. It's measured in S, has a symbol S, and it's measured in voltamps. And the reactive power symbol is Q, and it's measured in kilovolt amps reactive, and then real power measured in watts, symbol is P. This phase angle is the phase angle of the current with relationship to the real power vector. Some definitions is the real power or true power, also known as true power, symbol P, power that performs work measured in watts. The reactive power, symbol Q, power that does not perform work, sometimes called wattless power, measured in voltamps reactive, VAR. Complex power, S, the vector sum of the true reactive power measured in voltamps. And apparent power, which is the magnitude of the complex power, which the magnitude is you square, you just get rid of the sign. That's what these two bars around the S are. That's magnitude. The magnitude of the complex power measured in volt amps. This is what you want your generator to supply to your house or to run your refrigerator, your stove, air conditioner, etc. Phase angle. This is the angle used to describe the phase between the voltage and the current. The larger the phase angle, the greater the reactive power generated by the system and the more waste of energy you have. Again, the apparent power denoted by S represents the total demand placed on the alternating current AC circuit, calculated as the product of the root mean squared voltage and the root mean squared current. Square root of the sum of the squares, Pythagorean theorem. Measured in volt amps, it represents the combination of real power, useful work, and reactive power, stored or released energy. It indicates total circuit demand. Key aspects of the real power denoted as P, is the power that drives the load, and purely resistive components like heating elements, incandescent light bulbs, voltage, and current are perfectly in phase, meaning all the supply power is converted to work. It's 100% efficient. Uses real power is the metric you see on your monthly electric bill, expressed in kilowatt hours. It is used to label the performance specifications of electronic appliances, such as output capacity of a heater or torque rating of a motor. The key aspects of the apparent power formula is S equals volt RMS times the current RMS equals the apparent power, or volt amps. The units of volt amps are kilovolt amperes. The relationship to others, it is the vector sum of the real power in watts and the reactive power Q in V volt amps reactive, defined by the equation S equals the square root of sum of the squares. The power factor is the ratio of real power to apparent power. PF equals real power divided by apparent power, and it represents efficiency. The important use for the sizing of electronic equipment, transformers, and generators, because it accounts for the total current flow, including the components that do no useful work, the inductors or the reactive components. So a little bit more definitions. The active versus reactive versus apparent. So active is real. Real active power actually used to perform work, heat, motion, measured in watts. Reactive, like again, sustains magnetic and electric fields, like in your secondary of your transformer. Your capacitors used for filtering. And inductive and capacitive load. It oscillates between the source and load. Apparent power, the total product of the voltage and current, higher than real power when reactances exist. Okay, why does it matter? The relationship between real power and apparent power is defined by the power factor, which is calculated power factor of the real power, or active power, or true power, divided by the apparent power. The power factor of 1 means that there is no reactive power, no wasted energy, and apparent power equals real power, perfect resistive load. A lower power factor, that is, of 0.7 or 70%, means that the apparent power is significantly higher than the real power, causing stress on the electrical system. Utility companies often impose penalties on industrial and commercial facilities with poor power factors because it forces the grid to supply excess current. So for official standards and guidelines regarding the power management and system sizing, refer to the National Electrical Manufacturing Association, NEMA, their link is right here, or the IEEE for authoritative engineering principles, and that link is right here. So now let's bring this home and use it to analyze what was wrong with our power supply and determine how to fix the problem. Recall that the JAMECO 20626 kit comes with the power transformer 29226. It's 115 volts, 60 hertz, secondary 12.6 voltage center tap at 2 amps. So that means there's 1 amp on both sides. So a power rating of 25. So 2 times 12.6 is roughly 25 volt amps. That's all it can do. You divide that by 2, that's 12 volt amps on either side. So we were trying to get 2 amps with 10 volts, that's 20 volt amps. This can only do 12 volt amps on either side. So when you can look that up on here and see that the JAMECO specs for that transformer. But so we picked one out, and we picked the 102-121 power transformer. It has 115 volts AC in at 60 hertz, 12.6 volts center tap, exactly the same, but at 4 amps per side. So that's 25 volt amps at the same time on either side, with a total rating of 50 volt amps of apparent power. You can see that transformer right here. The transformer footprint is a little bit bigger because you need more windings to get the extra 2 amps. This solves our energy problem. We still have one issue, which is that the LM317T needs a constant current drawn from it, more than just the current drawn across the BE junction, voltage BE junction of the transistor to operate properly. And we observe in the schematic below, which I'll show you in a second, we are adding a 10 ohm, 10 watt power resistor to accomplish this task. The resistor will connect the output of the LM317T. This also includes the LM337T on the negative side to the positive leg of the power supply, as illustrated in figure 2. So here's figure 2. Now, without this right here, we have the schematic that came with the JAMECO kit. What I did is I cut this trace right here, inserted this 10 ohm, 10 watt resistor to keep the current flow out of the IC, but it doesn't exceed its ability. And then this NPN will be our current conduit. So the voltage here, we'll turn this on. We'll have a small VBE drop minus the output of that, and that'll come across here. Should be very easily to do a 5 volt, 2.5 watt, 2.5 ohm, 10 watt or 20 watt. Actually, it's 2 5 ohm resistors in parallel, 10 watts each. And I put them in parallel so I can lower the voltage to get 2 amps. And I got 5 volts out across a 2.5 ohm resistor equals 2 amps. So, and then we would just do the exact opposite here. We'd have our PNP, like the NP is here, and then we'd cut that and also put the 10 ohm, 10 watt resistor here. So after I've already installed the power transformer with the 2N 3055 power transistor and a 10 ohm, 10 watt power resistor. And so we're ready to go to the lab. Also, I'd just like you to remember that the PNP is an MJ2955. And it's the exact opposite of the 2N 3055. All right, off to the lab. Thank you. Welcome to the lab, 131B, where we complete our prototype to make sure that it works. We have installed our transformer with a 4 amp output with a 50.4 volt amp ability. We have our power transistor, which will be the conduit for the current going through the load. The load is a 2 ohm, 20 watts, because I have 2 5 ohm 10 watts put in parallel, which makes it a 2.5 ohm 20 watt resistor. I have that hooked in series with this meter right here, this DVM. I have it on 10 amps right here. I have one lead going into the 10 amp positive side, and then the other lead going into the ground side, putting it in series. If that doesn't make sense to you, please email me or comment me and I'll explain that to you. This meter right here is going to measure the output of the power supply on the positive side. Here is our 10 ohm, 10 watt resistor that goes from the output of the LM317T to the positive lug of the power supply. So we've got 2.5 volt 2.5 ohms. We're going to put 5 volts in. That should give us 2 amps out. The LM317T cannot put out 2 amps. So if it does put out and this reads 2 amps, that means the 2 amps is going through the transistor, the NPN transistor, and we'll be able to get 2 amps on both sides. So we need to power in our variac, plugging it in, turning it down, make sure it's down, turn the power on. I'm going to kick it up to 120 volts, as such. I got 5 volts across the power, this transistor. I got 2 amps, 1.99 amps going through that going through this transistor right here, going through the load. I have 5 volts dropped across that. Nothing's getting hot. Everything's working just fine. So this works. And you can scale this up to 10 amps, 15 amps, 20 amps. You just got to watch out, make sure your leads can handle that your traces on your board can handle that kind of current, and that your circuit can handle that current. And so you need a transformer that can put out, if you want to put out 10 amps, you probably need a 20 amp transformer that'll put out 10 amps on both sides. So this is going to grow exponentially. That's why this one's bigger. This has a bigger footprint than the one that came with the kit, the JAMECO kit. And so I can't just put it right back where the other one was. I'm going to have to mount it differently. And that's coming into the future. We will put all this into a case with analog meters to tell you how much negative voltage you have and how much positive voltage you have, and then the 3-lug banana jack inputs, on-off switch, etc., fuse. So that's into the future, but here it is. It works great. Thank you.
Here at Lab Rats Engineering, NextPCB is our one-stop solution for PCB manufacturing, PCB assembly, and DFM analysis. They offer a wide range of high-quality PCB services, including multi-layer HDI, flex, rigid flex, and metal core PCBs. NextPCB also provides complete turnkey PCBA services from component sourcing to assembly and functional testing, ensuring precision, reliability, and fast turnaround, with express options available in as little as 24 hours. What I really like is their professional support, fast shipping, and consistent build quality. Their one-on-one engineering service also helps ensure your design is optimized for manufacturing. If you're getting started, NextPCB offers a $20 discount on your first PCB order, which is essentially enough to get your first PCB made for free. Use NextPCB as your comprehensive solution.